Okay, good afternoon. I suppose just some background about myself. I'm a senior engineer with ARP just across the river in the Bridges Civil Structures team. I have worked with ARP in Brisbane, Hong Kong and London, so I have seen BIM in various shapes and forms at various different proficiency levels. And I suppose to say it out straight away, I'm not a technologist. I wouldn't know which button to press if I went into Revit, but I would like to see myself as a BIM practitioner, a facilitator, someone who encourages our younger staff, and I also have to sell it because, as Ted said, someone has to pay for it. So that's me in a nutshell. This is really going to focus on what we do from a consultancy point of view, with particular reference to the projects we've been working in infrastructure. And the reason why I chose infrastructure is because it is behind, and I'll explain a little later. I suppose, first of all, we won't labour on it, but what does BIM mean to you? And the reason I ask is that it means something different to everybody. I mean, whether you're a rail engineer, a highways engineer, whether you're a supplier, a vendor, a client, a contractor, it has a different meaning for everybody. And you know, we have our silos, and I think it's important that we understand that these have to come down, because otherwise it just does not work. So therein lies the challenge, and you know, we really have been modelling 3D since the 80s. So you could say, in some shape or form, we've been doing BIM since the 80s. But I suppose it's important to note that, you know, BIM is not just a 3D model. You know, Ted and Alan said it, that it really is using 3D models as a suite of tools, I suppose, to increase collaboration. And we like to see it as it's basically the efficient integration of models and design tools to increase collaboration and efficiencies, and that's key. You know, we don't want to be stuck in our silos as a rail engineer producing a 3D model that is no good to anyone but myself. So in the world of buildings, in recent years, building engineering has really taken a giant leap forward, and it really has become the status quo. In Europe, every buildings engineering project is BIM proficient. Every project has to adopt BIM. Whereas when you look at infrastructure, it's years behind, and we are trying to ask ourselves, why is that? The image you see here is a model, and it's one thing I want to point out, that I'm going to present a few projects. A lot of them are international, but they're all done across the river. So this is Riyadh Metro Station 1F8, which was done out of our Cork office. The structures, mechanical, electrical, public health, with the architecture being done in Toronto. And it's incredible to think that, you know, we could work on a live model 24 hours a day and produce a model, as you see on the screen, that's fully clash detected, ready to package up and send to site. So, I mean, you want to ask what's the benefit in it for the client. There you are. You get to site after your laborious design stage, and everyone has collaborated along the way, and everybody can see what each other is doing in real and live format. So the challenges for us, I mean, I like to think that if you take a building project, the complexity in building engineering is really the sheer number of elements, and it's trying to collaborate that number of elements between your structural engineer, your architect, your electrical engineer, your QS. But if you look at infrastructure, and in particular linear infrastructure, the complexity is not really in the sheer number of elements, but rather it's the complexity of the elements themselves. So if you think of a rail alignment, you take super elevation on a highway, you take a rail alignment, you look at a clothoid curvature as the rail goes around a bend, varying radius curves. How the hell do we model that? And that's something we've had huge trouble with in the last number of years. So, I mean, that's one of the challenges. The other challenge is, as Alan said, are the silos. I mean, we have an infrastructure group of 120 people, and we have huge silos. You know, rail engineers will only speak to each other, highways engineers the same. So we have to really break down those silos and I suppose get rid of the historic use of specialist software. Because the reality of it is, for BIM to work, you have to think of the end game, what's the output at the end. The other one is the interoperability that Ted mentioned. Not all softwares will handle different geometries. We need to be ambidextrous, and we need to use different softwares for different tasks. As I said, with the problem with handling the geometry, so for infrastructure, tools maturity isn't quite what we would like at the moment, but we're getting on. So I suppose really, I mean, what we're looking to do is to create this virtual cycle. And what the essence of the virtual cycle is that you get from one point to the other with the minimum amount of information lost or having to be recreated. That's the essence of BIM. We don't want to have to do things twice. You want to increase efficiencies. So if we start in the middle with your CDE, your platform, which is like your single source of information, and then you look at setting up your alignment, and this can be done in anything from Bentley MicroStation, AutoCAD, Civil 3D. Then the tricky part is to get from that into your actual 3D model. And then if you look further, we want to get into the analysis, and as Ted has been mentioning, there's always bugs and always errors and always problems with the interoperability between softwares. So, I mean, the challenge is to get that virtual cycle without having to recreate things, and we're not quite there yet, but we feel we're making a good handle of it, and I'll explain a little how. There's a software, an example of where we tried to use that with very little success, but have learnt a lot of lessons, is a project in Canada. So this is Edmonton LRT. Designed, it's a 13-kilometre railway viaduct. 1.3 kilometres of this was designed here in Cork, with the station in the middle. There was 38 spans of varying length geometry, and because of it's a rail viaduct, we have complex alignment with clothoid curvature. So the way we tackled it is we took a look at the functional cross section. Because you have varying radius curves, we could have rationalised the curves and made the viaduct or the girder a lot bigger than it needed to be, and just said, okay, contractor, you can build it to a constant curve, and once it's outside of our rail envelope, all is good. But we had huge problems with corridors, we had right-of-way issues, and also we wanted to increase the repetition between spans. So we looked at what package could we use. Revit was the choice because it was being used right across the project with the station design, with the tunnelling. So we were kind of stuck with Revit, so we had to look at a workflow that would allow us to produce our final 3D model. How we get there was the big challenge. So the way we set it up was we were able to take the actual alignment file as a set of control points out and into Excel, and using these we imported them into Civil 3D, and we were able to develop a rail envelope, and using the composer within Civil 3D, we were able to model an assembly, which is effectively just the girder geometry, and sweep it through the swept path of the rail corridor to come up with a solid object. That solid object then was transferred into Revit, and as Revit users will know, in there then we could model all the piers, the pile caps piles, using Revit families. Now the crux here is that solid object had no smarts. It came from Civil 3D as a solid. If we wanted to manipulate it, we had to go back to the start. So we were really doing things twice. If we ever had a change in the rail alignment, if we wanted to thicken the webs or thicken the bottom slab or whatever, we had to go back and do it again. So it wasn't ideal, and we struggled on. Program meant that we had to deliver. We was a design and build contractor with a contractor breathing down our back. So this just gives you a basic summary of the workflow. But what we've been looking at the moment with Metro North is the same workflow, but sticking Dynamo in the middle. So we do the same thing. We get the rail alignment as a set of control points into Civil 3D. We set up the alignment in Civil 3D, and then using Dynamo we can control the variables. So you set up, using assemblies again, same thing, we set up a variable dimension. Rather than giving it a fixed dimension, we set up a variable, and in Dynamo we can actually set up our spaghetti, as a lot of people call it, but what it is a set of commands that tell you, I want you to do A when B occurs, and it's really programming, but there's huge smarts behind it. And what it means then is now we have a Revit model that's fully parametric, with any changes that needed to be made, they could be made within the alignment, within Dynamo, but all the time your Revit model, and in the end your 2D drawing files which come from your Revit model, are parametric with the alignment. So we found there was great benefits in that. I suppose just going back to the benefits for the contractors or for the end users, I mean, when you design in 3D, it gives you a huge understanding of the process. It gives your design teams understanding of how things are put together. It gives the contractor the ability to critique your design as it progresses. You'll see there on the right hand side, that's a rebar model of the pier. And the challenge here was the contractor couldn't figure out how he was going to withdraw his tremie pipe, a very simple problem that everybody experiences on site. So we were able to model the rebar, model the tremie pipe, and prove to him that you don't need to take it out, you can leave it in. Very simple, but very effective to the contractor. In the middle you see the bearing to diaphragm connection, which I don't think I've worked on a bridge project where that hasn't caused huge headaches. And really what it is just the area of most congestion. You have huge amount of reinforcement, your bearing pad has to be anchored in, so you have all this going on in the one area. So we were able to model it to figure out how the hell does this go together, and that model was shared with the bearing suppliers, who then could set out their bearing studs, their shear studs, to match our rebar layout. On the bottom left is a simple utilities model which shows a water main passing through our pile cap. Would you relocate the water main? No, we were able to say, well look, why don't we shift the pile cap half a metre and we can cast the water main within the pile cap. So all these things are made in the design office during the design development before you go and scratch your head on site and say, oh bugger, we have a problem here. So the thing is that you're doing all of this up front, so there's huge benefit to the contractor. This is just a Navisworks clash detection model, which shows how we were able to do a virtual design review on a weekly basis. We were able to import all of the utilities models in with the structures model, and you were able to do a real-time virtual design review. These are just images really of the station. The station architecture and SMEP were designed from the same live model. And I suppose the last one, I just want to show a quick video which shows a very quick 15-minute production, just showing the driver's perspective as you run along the alignment. I suppose as it's flicking through that, I just want to say that, this is a detailed design project that required the output was detailed design to construction level of detail. So we had to tackle that in a certain way. We needed certain software to deliver the objectives that our client wanted. Now the next project is the N6 Galway Outer Ring Road. Now that's a concept stage, that's going for public procurement, for public consultation. So we had to take a different approach. Our drivers now were, how do we get optimum alignments? How do we do multiple alignments? How do we do visual fly-throughs? How do we engage the public? How do we engage the client? We don't care about the level of detail. We don't care whether we're going to do rebar. We don't care whether it's down to the nearest millimetre. Our issues here where we had to do this fast and we had to do it with a lot of visual impact. So here you can see a junction. This is InfoWorks taking a MX Roads road alignment and bringing it into InfoWorks. So very visually impactful, and this was able, then we were able to create visual fly-throughs that allowed the client to see what was being planned. Again, this is a LiDAR survey of an existing quarry. You add the detail, you add the GIS mapping, and then you bring it into InfoWorks, you add the road layout, and again, here we are, very quickly, in a couple of weeks, we're able to produce something that's very visually impactful and allows us to bring the client and the public along with us. Now, we talk about different levels of BIM, and I suppose the Edmonton project was probably level 2. This is a project that I'm not directly involved with, but it's our colleagues in Amsterdam, and I wanted to include it because this is where I think we need to get to. This is probably level 4. What you have here is the Soerhofbrugge in the Netherlands. On the left-hand side is an existing rail viaduct adjacent to an existing highway viaduct. And the issue here was that the vibrations from the rail were causing fatigue issues in the bridge. So the decision was to construct a new steel arch bridge and move all of the road traffic off the bridge. Then you could do your fatigue repairs to your rail bridge and then reopen the road bridge once the repairs were done. Now, this was a multidisciplinary approach. ARP were doing the structural design, Royal Haskoni were doing the highways alignment, and the client very bravely decided, I don't want 2D drawings, I want a full 3D model. That is my deliverable. I wanted to have 4D with construction sequencing, I wanted to have 5D with costing, I want every element modelled, I want the existing bridge modelled in the same level of detail as the new bridge. And there is the vision that we probably lack a little bit. It costs, but it is the future. It's it's something that has to be seen to be believed, I believe. I think that the clients have to really touch and feel this and construct them and see the benefits before they'll actually make the investments. But this is why we're all here. We're trying to push the agenda and make people realise that this is what the future is. So this is that's the Navisworks model. I suppose a little closer to home then is Harley Street Bridge, which is just behind us here, going for construction in the summer. This is probably where we lacked a bit of collaboration. Our architects wouldn't share grasshopper models, so we had to create a Dynamo script to basically compare directly with theirs, because I suppose if I get into detail, the actual geometry of this bridge was quite complex. It was formed with three-dimensional curves cut from an inclined cylinder. So we had to really make sure that we met the architectural vision. We had to produce the script, guessing the script that they had produced by setting up parameters that we didn't really know would work. But if we had to draw this in 2D, we'd be still drawing it. The reality of it is we could play with the scripting in Dynamo, and we could actually test it, prod it, send back Revit models to the architect, get them to tell us yeah or nay, you're in line with what we have. And now what we have is we've got a 3D model that now can be used further. There's potential for the fabricator to use the model. There's no potential for us to do fly-throughs and all that kind of automation. But I suppose the essence of this is if we had to draw this 10 years ago, we'd be still drawing. The reality of it is we were able to create something parametric, and we were able to push and prod it and test it until we got what we felt was the right solution. Ted mentioned the public or the flood relief work. Very contentious project at the moment. And I suppose what is important is that, and I'll throw on the video and skip along a little bit. So in collaboration with the OPW, this is the Morrison Island package. And the vision here is that we're going to have a new city centre environment incorporating the flood relief works and a high-end public realm. Now, I suppose the reason why we went and invested in this level of detail was that we felt that it would serve the public better if they saw it in real time, if they saw fly-throughs. But in fact, where it actually caught us out was that the client himself didn't really have the vision and wanted to see it. And as the fly-throughs were being produced, the design started to rapidly change. So what was a set of 2D drawings became a set of visual fly-throughs, but what it also meant is that the client really got to touch and feel it and figure out what they wanted, and then it took on a life of its own. So, I suppose why I'm showing it is it shows what the power of what can be achieved. This is a set of 2D drawings that were converted into civil 3D. It was LiDAR sketches, or LiDAR surveys, and then all of that was brought in the civil 3D, and then we were able to use Studio Max to create the animations. So again, look, if we were to show a set of 2D drawings to the public, would they really buy it? Will they really buy this? I'm not so sure, but we're trying. So I suppose that just gives an example of what can be achieved in a very short space of time. I suppose where are we now? We have made significant strides in 3D modelling. BIM is not 3D modelling, I know, but as Ted said, we have to go through that process before we can bring it to the next level. And we feel that we're getting there. Infrastructure, as I said, is probably a few years behind buildings, but we feel like if we can break down the silos and if we can think outside the box, we can catch up quite quickly. And the thing about it is the benefits to infrastructure projects of BIM far outweigh, I would imagine, far outweigh what the benefits are to building projects because of the sheer scale and cost. We've developed robust workflows that we have tried to break down the silos and integrate the specialist disciplines. We've used things like Grasshopper and Dynamo to help us define the geometry, to get over the issues that we have with software, because as Ted said, Revit sometimes can't model curvature like we would want, but we've figured out that there are options to get around that. Staff training. We have to be ambidextrous. The day of somebody coming in and saying that I'm a specialist and Revit is gone, you have to be proficient in multiple softwares and be willing to use all softwares, because the reality of it is you have to look at the bigger picture, and every BIM deliverable will require multiple software. And then you have to experiment. You know, we won't get there until we invest and until we see and prod and figure out what it is we want to achieve and what we need to do to get there. And then I suppose the most important thing is the client engagement. Someone has to pay for it, unfortunately, and I think we really need to sell. And I don't think engineers are very good salespeople, but we have to try, because the reality of it is, if we're to take it to the next level, we have to be given the opportunity to produce. So that's it. Thank you.